In this lesson, we're going to discuss the law of definite proportions and the law of the conservation of mass. When we look at the law of definite proportions, we're looking at a single compound. For example, if we're looking at water, or H2O, what we find is that that compound exists at a fixed ratio by mass of its component elements. And it doesn't matter where that compound came from. If it's the same compound and we look at that mass ratio, we're going to see the exact same thing. So if we took a sample of rainwater, a sample of water from the tap, or a sample of water from the lake, those water molecules are going to have the exact same ratio by mass. So for example, for water, the mass ratio of oxygen to hydrogen is 8:1. Now, if we look at a different compound, such as H2O2, it still has a fixed ratio of oxygen and hydrogen, but it's going to be different than it is for water. So let's look at CO and CO2. What we see is that they have a different ratio of masses, but we're still going to have that fixed ratio. So all CO are the same ratio and all CO2 molecules are the same ratio, but they're different from one another. The law of conservation mass tells us that in a chemical reaction, mass is always conserved. This is not true when you look at a nuclear reaction, but we're not going to be dealing with any nuclear reactions in this course. We're only going to focus on chemical reactions. And what we see is that mass is conserved. So if we start with 4 carbon atoms on the left side, we're going to have 4 carbon atoms on the right. And we'll learn more about how we write balanced equations later on. Right now, we just need to remember that everything that's on the left side of the reaction has to be there on the right side of the reaction in some form. And when we look at these different representations, they all tell us the same thing, just in different ways. But what we see at the very bottom here, we see on the left, we have 1 carbon atom, which is the black atom there, the dark gray, 4 hydrogen atoms, so the white spheres, and 4 oxygen atoms, which are the red spheres. On the product side, or the right side of the reaction, we have 1 carbon atom, the gray sphere, 4 hydrogen atoms, which are on the 2 water molecules in these 4, and then 4 oxygen atoms. So the 4 red are oxygen. So we see the exact same atoms on the left side and the right side. They've changed how they're connected to one another, and so the molecules look different, but the mass is conserved. If we look at an example with a closed system, so we have a sample of phosphorus, we have some water at the bottom, and we have air filling this container. Once the reaction occurs, we now have the air, but the oxygen has been removed from it. Phosphorus oxide, so the phosphorus reacted with the oxygen in the air, and we still have water. And what we notice at all 3 points in this reaction is that the mass is exactly the same. We may changes in energy, changes in temperature, but the mass is the same. And that is the law of conservation of mass.